Hi, my name is Abdullah Imran, and for this video I will explain on how to create this ALU design in Quarters Prime. For overall view, this project will be consist of 2 4-to-1 multiplexer, 1 adder subtractor and 1 register. To create this 4-bit 4-to-1 multiplexer, first we need to create a 1-bit 4-to-1 multiplexer first. First, I will explain on this 1-bit 4-to-1 multiplexer. For this multiplexer, it will be contained with 4 input, which is I0, I1, I2 and I3, which also will be connected to 1 AND gate for each input, while there is 2 selector, which is S0 and S1, and it's also connected with NOT gate. The selector 0 without NOT gate will connected to AND gate that contain input I2 and I3, while the selector 0 with NOT gate will be connected with AND gate that contain input I0 and I1. For the selector 1, just inverse it with the selector 0, which is without the NOT gate, it will be connected to input I0 and I1, and with NOT gate, the selector 1 will be connected by using AND gate with I3 and I4. For the final output Y, we can obtain it by combine all the AND output by using OR gates. After simulate the circuit, press create or update, then press correct symbol to create the 4-to-1 multiplexer block that we will be used for the next step. For this part, I will explain about this 4-bit 4-to-1 multiplexer. From previous simulation, we already obtained 1-bit 4-to-1 multiplexer, and we can paste it from library and use it in our block diagram. As you can see, we have 4 blocks of 4-to-1 multiplexer, and for this 4-bit multiplexer, there is 4 inputs with 1 selector's input. For the inputs, we need to connect it to the multiplexer by following the label input on each of the multiplexer. Since we're using bus line, we need to label all the input to make this block diagram functioning. For the example, input 0, for the first multiplexer, we will be label it by I00, for the second one, I01, for the third one, I02, and the last one, I03. For the output, we will connect it using bus line from Y0, Y1, Y2, and Y3. And that's all for 4-bit 4-to-1 multiplexer. And we will go to the next part. This is the second part, which I will be explaining on the arithmetic function, which is adder subtractor. So first, we already built a full adder, which consists of input A and input B and carry in. We will be using this circuit for our next block diagram. So this is where we will be using the full adder. This is the block diagram of 4-bit adder subtractor. Since we have 4 inputs, which is A0, A1, A2, and A3, label it on the bus line and connect it to each of the full adder first. And for the input B, connect it to the XOR gate from B0 until B3 and connect it with ALU OP. And this part is where it will determine either we will do addition or subtraction, which when ALU OP is 0, we will be doing an addition, and when the ALU OP is 1, we will do a subtraction. And for the output S, connect it using bus line from S0 to S3 to 1 output. And for reminder, we need to save all the multiplexer, adder subtractor, and the following register to the library, and we need to use the component for the last compilation. And the final component in this ALU design is register. For this register, we will need to have 3 input, which is D from 0 to 3, clock, and reset. Since we are having a 4-bit, we need to have 4 D flip-flop for our register. Connect all the input of D starting from 0 to 3 by using a bus line to every flip-flop. For clock and reset, just connect it to each of the flip-flop. So we will get our final output as Q from 0 to 3 by connecting all the flip-flop using a bus line. So that's all the component that we need to design our ALU. So we will compile it into one block diagram. As you can see, this is our final product of ALU design after compiling all the 3 components that we already create from previous. Before going to the timing diagram, we need to compile this file and run a simulation and see whether this block diagram will run or not. And for this final part, I will be explaining on how this timing diagram functional after running the simulation. As you can see, for the first 2 positive clock, there is no changes since the reset is 0, and we will be focusing on the third positive clock, which is when the reset is 1, the input of A cell will become 10, which is 2, and our A2 is 1001, and our input of B cell on the third positive clock is 00, which is equal to 0, and we can see our B0 is 1100, and since our ALU OP is 0, we will be doing an addition. So for the addition of 1001 and 1100, we can get 0101 as input Q on the below. And if the ALU OP is 1, we will do an subtraction. And this is all from our group. Thank you.